Hey, we're going to do two questions that involve integration. The first one is integration by substitution, and it's a definite integral because it's between 1 and 4. And the second one is integration by parts. So this will be by substitution, this will be by parts. And let's explore that. So here, when you're doing substitution, what you want to do, you want to call one of your part of the equation u. So always take the more complicated part and call it u. So let u equal x squared plus x minus 1, and du will be, taking the derivative of that, will be 2x plus 1, all of that, and then dx. Okay, so now this is actually straightforward, because now if we do in substitution, and I'm just going to ignore the 1 and 4 right now till we finish integrating this. So already this 2x plus 1 dx, that's already there, so we don't have to manipulate anything. So we call that du on top right there, all of this. And then this part right here, we're just going to call it u. Now to integrate this, when u is on the bottom, you know the integration of this is ln u. Now this is done. Next thing you're going to do, just sub in the u value, which is x squared plus x minus 1 right there. And then you'll go ln x squared plus x minus 1. And that would be between 1 and 4 because it's a definite integral. Now what I'm going to do, you take the upper bound and you sub it into here. So that's 4, 16, 16 plus 4 is 20, 20 minus 1 is 19. So this will give you ln. Maybe I'll just write it out. Minus ln, and you sub in the 1 as well. So now that will give you ln 19 minus ln 1. Ln 1 is 0, so the final answer will be ln 19 for this. So this is just a simple way of doing substitution. Now we're going to go to integration, which is a little bit more challenging than substitution. So the thing here is you want to identify two things here. You know, what you're integrating is u and dv, so you got to call one of them u and one of them is dv. I'm going to let u be x and dv be root x plus 1, which means dv is x plus 1 to the power of 1/2. Now you could ask a question and say, why, Sami, can't you do substitution in here? Well, substitution, if I want to make this u right here, when you take the derivative, so if you let u equal x plus 1 and you take du, you're going to get 1. Now, this is not 1, this is x. How are you going to make up for that x? So that's why you cannot integrate this using substitution, because in substitution, once you do this, let it u and then take du, you should get something like this, or even something like you could manipulate and make it into x plus 1. You know, let's say it has to be a different example, but you just have to manipulate this part to make it match this, but this matches already. So and then when I say match, you either let's say, okay, let's say this was let's say the u was x squared plus 2x minus 1. And then when you did du, you get 2x plus 2, you know. And let's say the equation, the question here for this, ignore that question. So the question was integrate x plus 1 over x squared plus 2x minus 1. So maybe this, I worked backwards kind of this now. So if I give you this and I go dx right here and I say integrate this, now if you let u be this and when you take the derivative of u, you get this. This is not exactly that, is it? But it's very easy to make it that by multiplying this by 2 right here. But if you multiply this by 2, make sure you put a half outside, because half times 2 is 1. You'll have to balance the equation. And so multiplying by 1 doesn't change it in quantity, but it will make it match the du right here. So that's what I mean. If you could manipulate this to make it this when you're doing substitution, but when you have an x like that, you cannot do that. So here, the only way, you cannot say I'm going to introduce an x. You're not allowed to do that. But the only way you could do this is by integration by parts. I hope I didn't confuse you there. So now just let's focus on working on the integration by parts. So as I say, I let u be, or I let u be x or equal x. Maybe I should write equal x. Yeah, so we need the space anyways. So this here, I let it to be this part of the equation. And the dv, I let it be this part of the equation. So basically you're matching these here with these. Now, du here equals 1. And here it's dv, so you have to integrate this to make it v. So let's work from here. If I have dv to be this, then v would be x plus 1 half, and you add 1 to the half. That's how you integrate. And then whatever you do, you get here, you gotta divide everything by that, which is the half plus 1. What does that give me? Half plus 1, that is going to give you 2 over 2 plus 1 half. It's going to be x plus 1 to the 3 halves. And this is going to be 3 halves as well. So dividing by 3 halves is the same as multiplying by 2/3. So that's how this thing is going to be. So now let's go ahead and integrate now. So integrating x square root of x plus 1 would equal v, which we already know now it's this. That's what v is. So 2/3 x plus 1 to the 3 halves v, which is times x, minus the integration of v. If you just give me a second, I'm going to move all of this to the top here and then be able to fit all of this in there. So minus v, which is 2/3 x plus 1 to the power of 3 halves times du. Du is already 1, so you don't even have, should write dx here. So du is already 1, so 1 dx. So you don't have to write 1 here, but we just write dx. And now, of course, when we did that, we should have had the integration sign right there. Of course, that's being integrated, all of this now. So the answer would be 2/3 x plus 1 to the 3 halves minus, now if we're going to start integrating this, we have the 2/3 here. The x plus 1, you're just integrating this, like you could just put the 2/3 right in front of here. You don't have to bother with the 2/3, but you're integrating this. And now you have to add 1 here. So if you add 1 to this, it's the same as adding 2 over 2 to this. So this becomes 5 over 2. And then you have to divide by 5 over 2, which gives you 2/3 x plus 1 to the 3 halves minus You're going to bring this to the top and flip it so it becomes 2 over 5. So that will give me 4 over 15 brackets x plus 1 to the 5 halves. And it's always important to write plus c at the end, because when we integrate, we still have to write plus c at the end. I think I missed that in some videos I did before. So we tell students not to miss that plus c at the end when you're integrating, unless you do an indefinite integral. And that's it. So this is integration by substitution. This is integration by parts. So this is it for integration by substitution, integration by parts. Stay tuned for my next video. Thanks for watching. Don't forget to hit that like button, subscribe, and share with others so they could benefit. Till next time, ciao.